So it says in 1 through 6, find the limit as x approaches a of f of x. So x approaches a. Well, that means that I'm coming from the left and coming from the right on x. So x is going like this. But it's forcing y to occur. So as x moves in, y moves in. The question is, do these two arrows meet? Do they?
Yeah.
Will my fingers touch? I can say that the limit as x approaches a of f of x equals what? Where do they meet? They meet at B. So Howard and Harriet meet at the top of the peak. There's no place for each of them to stand, but that's okay. Their antennas can touch. And they're happy little ants. Now, the limit as x approaches a of f of x. Now, remember, x is coming in towards a. That means here comes Howard. Here comes Harriet. Do they meet? No. Howard ends up down here. Harriet ends up there. So at which point do they get together at all? No. So if they don't touch, or if they don't appear to touch, what do I know about this limit? There isn't one. They don't share the same y value. They don't share the same space. They don't share. It's like Howard ended up on the beach and Harriet was up top on the cliff. The best they can do is they can wave their antennas each other. They can't get even close. So we would say does not exist, which would be D N E. That's an easy way to write it. Does not exist. Now, if I wanted to use my fingers, I'd just run my finger from the left, run my finger to the right, and I notice that my fingers don't touch. When I get to A, they're not touching. If they're not touching, there's no limit. Here, if I run my fingers from the left, run my fingers from the right, they meet, and they're going to touch, and I look over to see what's the y value where they touch. It's B. You're on the graph. X tells you what it's doing. You want to know what y is going to do.
On a graph like that first one there,
Mm-hmm.
is it always going to be symmetrical?
No. You can have it as humpy as you like. Would be nice if it were, but it's not. Find the indicated limits. Now, this is easy. Step one, what am I going to do?
Plug in -1.
Plug it in, yeah, plug it in. And then that tells me number in, number out, got the limit, done. Number in, something else happens, I got a problem, and then I need to know how to handle that problem. So, plug it in, and remember the limit's a y value, so this is going to be 1 cubed minus 2 times 1 squared plus 1 minus 3, which is 1 minus 2 minus 2, which is minus 4 plus 1, or minus 3. Who is negative 1? Oh, I didn't see that. Negative 1, negative 1, negative 1. That's going to change everything, isn't it? Where's my white tape when I need it? I'll have to video this next hour. So this is going to be negative 1 cubed is negative 1. 2 times this is going to be a negative 2 times 1 minus 1 minus 3. Let's see if we got it now. This is minus 2 minus 1 minus 2 minus 4 is minus 7. That should be what the limit is. Did I drop? No, I didn't drop a sign. Okay. Phew. So what am I going to do here? What's the first thing you do?
Find the zeros.
No, what's the first thing you do?
Plug it in.
Plug it in. Remember, we're finding the limit. It says find the limit as x approaches 1 of 2x plus 3 over x plus 1. So at which point you plug it in. The only time I need to worry about finding the zeros is if I get a 0 over 0 form. But as long as I put a number in, get a number out, that's all she wrote, I'm done. I got the limit. I mean, limits are actually pretty easy. This is 2 times 1, hopefully this time it's a 1, plus 3 over 1 plus 1, which is 5 over 2, so the limit is 5 halves.